Okay, I just thought I'd try to throw together a quick video tutorial intro to Robot Builder. Kind of the goal of this is to kind of show how to use Eclipse and Robot Builder together to create a kind of simple robot program. What I'm going to do is try and design a basic program for controlling last year's Yokebot robot for Team 5725, just to get ready for this year's kind of kickoff and build season. So first thing you're going to do once you're in Eclipse here, you actually want to start and do most of what we want to do in terms of our setup. We want to do within Robot Builder. So you just click on this little kind of red icon right here. It's going to open up Robot Builder. Now you can see I have a project open already, but I'm just going to go File, and I'm just going to go up here. I'm going to go New, maybe this new robot. I'm just going to call it Robot 1 as my project name, and then our team name is 5725. And so make sure you put your team number in there, and then we just want to create a project here. Now what you can see from within Robot Builder right away is it's kind of has some basic folders here that contain your main components that you're going to need in your program. It has subsystems, operator interface, that's where you're going to put kind of event handler kind of stuff, joystick control, those kind of things there, and then commands that actually do stuff with your robot. So it's actually in a really good order here too, in that it's set up with subsystems first. So the first thing what I want to do, I want to right click on subsystems. I don't like the drag and drop method just of adding subsystems. I'd rather right click, and then we're going to add a subsystem. For the sake of this Yokebot robot, they didn't have any PID subsystems with a potentiometer, so I had to kind of think of different creative ways to control things like the elevator, where I can't move to set points. Hopefully in a future video I can go through PID subsystems, but I'm not going to cover that in this video. So we're just going to add a subsystem here. The first one we're going to add, we're going to call Drivetrain. Okay, and then default command, we'll get to that once we have some commands established. Make sure you hit enter, and then it adds that Drivetrain to our subsystem there. And so that's our first one. What we want that drivetrain to be is we actually have, it's a tank drive kind of set up for our robot. So we're going to click on add robot drive 2, and then you can see that that added some things here. Now the red tells me that there's something incomplete here. So in my robot drive, there's going to be actually two sides to that, and so I need to decide what I have there for my two speed controllers. So I'm going to add a speed controller here, and ours are actually talent speed controllers. I like to add in the left side first because of a function that we have. So I'm just going to type in there left motor, and it is of the type talent. You can see there's lots of things you can select here. If you have a Victor or whatever, you can do that. Ours are talons, and my left motor, actually it's going to be wired to PWM1, and so I can put that in there. Now the next thing, again, I can right click on robot drive. I need to add another speed controller for the other side, and it's again a talon. It is actually set to output channel 0, but I'm just going to call this right motor. And then you can see it's still red on that robot drive. And actually, I'm going to rename that robot drive too. I'm going to call it just drive. And then I'm just going to have to change one of these. So the left motor, it says drivetrain left motor, drivetrain left motor. Well, I don't want that. I want to reset this to the right one. And then you can see I have my drivetrain set up. It's got a robot drive. It's got left motor and right motor. And so that's set up and working. So that would be the basis to my drivetrain subsystem. While I'm adding subsystems, another thing that we're going to have, and the only other thing we're going to have under subsystems, and normally it would probably be a PID subsystem if it had a potentiometer, would be the elevator. But in this case, we don't have that luxury. So we're just going to do a regular subsystem, and we're just going to call this one elevator, and go from there. So enter. And so we have my two subsystems set up. Now, from this point, I want to think, okay, well, what else can I do while I'm still within RobotBuilder before I move into Eclipse? Well, I have my two subsystems set up. And from there, actually, inside here, I want to maybe add in a speed controller for my elevator. So actually, for my elevator, I need a speed controller. And I believe our speed controller is a Victor for my elevator. And while I'm inside there, I should also add in, this would be, I'm just going to call this drive as well. Could call it motor or something. And my elevator PWM channel, I'm going to have to try and check what I have for that. We'll leave it for that 2 for right now, but I'm not sure if that's 100% correct. Yeah, I'll leave that at 2. I think that might be right anyways. I think it is. So we'll just leave that Victor as its output channel as 2. Okay, and so that should be the setup for our subsystems. The next thing I want to set up, I do want to set up my operator interface. A couple things, we're going to use an Xbox One controller for the tank drive. Makes sense with the 2 kind of joysticks. Talk about reading the joysticks a little bit later. I'm going to add as well some buttons. The joysticks are going to control the operation of our actual tank drive system, or drivetrain, and then we're going to have buttons controlling the elevator. I'm going to have a couple sets of buttons. One set of button is going to just, while held down, it's going to move the elevator up, and the other button, when it's held down, will move it down. And then we're going to have another set of buttons that kind of increments that elevator up on 1 second kind of time intervals. Because we don't have a set point like a PID subsystem would have, we're just going to use that kind of timing system, the kind of timed out system. So I'll show you that in a bit. But let's talk about the operator interface. Like I said, this is kind of what I think of as like your event handlers in other programming paradigms. So what we want to take a look here at, I want to add first a joystick, and I'm just going to call my joystick Xbox One, and I believe that our controller is connected to our input number 2. Okay, so we'll leave that there. Let's also add some buttons. I'm going to add buttons. I'm going to be very specific in naming these. Notice I don't have a command in here right now, but I think the first button I'm going to say elevator. I call it elevator up. And that's just going to, when I hold the button down, it's going to move the elevator up. I'm going to put that there. That's good enough there. We will have to set, I'll have to take a look at what that, I want to kind of map that to in a minute. We're going to add another button. It's going to be elevator down. I'll link these up in a bit. Default command we don't have in yet. I'm just going to set that to 1 for now. I'm going to have to change these. We have another one. It's going to, I'm going to call it elevator increment up. Once again, I'll just set that after. And down. And I'll set this for fat. So that's going to be our 4 buttons. The rest we're going to just control with the joystick. Get a reading straight from the joysticks. So that's a fairly good setup. Now the last thing we're going to set up before we move into actual Eclipse is some commands. So I'm going to add a couple of commands here. First command is going to be drive with joysticks. It's going to require Drivetrain. Next one I'm going to add in is we're just going to make it match our buttons. Elevator up. And we have the component. So we don't just come out, I'll just put a space. Elevator up. That's going to require elevator. A few more commands here. I'm running a little bit over time. Let's first set up the video, start of the video. Elevator down. There's elevator. And the other ones can match. Elevator, increment, up, there's elevator, go from there, and then also add command, elevator, increment down, the elevator is what it requires. Other things that I'm going to add in here that maybe I might as well just add them right now. I'm going to add, I could have probably put set point commands forward. I'll just do that by default on these ones. I could have had increment up and increment down being set point commands. Actually, no, I couldn't. So we'll just do a command because we can't use set points, no PID control. So I'm going to add another command here. I'm going to call just drive forward. I'm going to use this for a little bit of autonomous stuff that we're going to do. It's going to be Drivetrain. We're going to do another command that I'm going to call drive back. Add that in. It's going to be our Drivetrain. I'm just going to use that for autonomous. And then from there, I'm going to add one command group that we're just going to use for the command or for the autonomous period. And I'm just going to call it practice auto. And we'll just leave that as is. Okay, so we have almost everything set up in RobotBuilder. You're going to see this is generating a lot of code for us without actually coding, which is nice. So a couple things I just want to check here before we move on. Elevator up. I want to kind of set these button numbers, and I've just done that based on Xbox controller buttons. So I just need to kind of take a look at what I have there and the way I want to operate this, just so this would work. So button number, elevator up, I need to set that up to, I want that to be on button number 3. We're going to add the command for that right now too. So I want that to be on elevator up. So I just added the command and then it's not going to be read anymore. Elevator down. I want that set to my Xbox button. Okay, just continuing on here. We're just going through. We set elevator up to button number 3. and we set that to the command elevator up as its command over here as well. Notice that when to run, we have it's set to well held, okay, which is what we want in this case for these first two buttons. When the elevator button up's held and the elevator button down's held, we just want it moving up and down. Is what we want for those two. Now these next two commands are going to be, it's going to move up or down for 1 second. So for these two commands, I don't want that to be the same kind of event to trigger that. I want it to be when pressed. So let's move on to those ones. Again, I need to kind of quickly look up the button number on my Xbox controller for that, which is this one is increment up. I want set to button number 1. So that is the default command, of course, is going to be increment up. And I want this to happen when pressed. So just a different kind of event that triggers that command. And then here, we're going to again set this up. I want increment down to be obviously the default. Increment down is going to be the command there for that, and I want that to run as well when pressed. And that's going to be controlled by button number 2. And so things should be all set up. So you can see we have the different parts within RobotBuilder. Has done a lot of work for us already. It's done some work in the robot map that I'll talk about in a bit. We have all our commands there, everything that we want our robot to be able to do. And we haven't wrote a line of code yet. So now I'm just going to save this project somewhere. I called this start from. I guess I just named it robot. Okay. There we go. So I'll just save this. I'll just call it robot one. And we'll save that in the documents. This is just a YAML file. This just is saves this kind of this configuration here as its own project. It's kind of a map there of the project. So you just save that. And then what we actually want to do from here, though, is we want to actually generate some Java code into Eclipse as a project. And as soon as I hit this Java button here, this is going to turn this into an Eclipse project for me that I just need to import. But let's check where we want this to go. So because I do Android programming as well, my workspace is not under my username workspace. I'm going to actually keep my robotics one a little bit separate. It would be under robotics and then workspace. So and for right now, we'll keep that as an absolute path for now. We do want to change this to a relative path. If you're someone that's using just a workspace underneath your username, but for now, let's just leave that there. So you see that's where that's going to put the Eclipse workspace, and then I can move back and forth between RobotBuilder and Eclipse. So let's get to it, though. Let's just generate some Java code. And so when I do that, it should say down here, you've successfully exported. And then I can jump into inside my Eclipse here. Remember, I launched RobotBuilder from here. And then now I just need to import this in so that it sees it within the workspace, existing project into workspace. And I don't need to copy project into because it's already in there. I just need to be able to recognize. I think I just call this one robot. Click OK. And nothing else here needs to be kind of checked. Click finish. And you can see already I have a command-based project that started. I have all my commands that are already there. I have a drivetrain and an elevator. And now that's the next thing that we'll do is we're just going to set those up. But let's just take a look in this OI. And you can see what this has already done for us. Notice it has this auto-generated code, begin and end of auto-generated code. It's important we type outside of that when we add new things if we want to continue to use RobotBuilder. And so from there, it's got my joysticks, my joystick buttons that I'm going to use. It's all got those already set to, as a van handlers to what it needs them to be set to. Notice this is when pressed, and we're all good there. Okay, and it also adds all these things to Smart Dashboard, which is a topic for another lesson, but this is a bunch of extra code that was already done for you, so that you can work with the Smart Dashboard, which is awesome. So, that's our OI. Obviously, we've got some code that's added to our robot. You can see anything that's kind of any kind of subsystems are initialized right within that robot init, and that those are going to be ready to go from there. And I should be able to operate their default commands from there. Look, it's got autonomous here. Eventually, we'll set that to practice autonomous. I'm not sure if we'll get to that this lesson. We'll see. But yeah, it's we're definitely getting to where we need to get to now. It's got the autonomous here. It's going to be initialized there too. So this is all set up, all done for us. And the same thing within robot map, which is where you would store and initialize things and be accessed everywhere. Both my Talon motors are initialized there. You can see that stuff, and my Victor's initialized there too for my elevator. And it's set these properties that I don't need to worry about and think about. So it takes care of a lot of that kind of repetitive code for us. Now we can get right into taking a look at programming the drivetrain. So,
okay, looking inside our first subsystem here, drivetrain. What we have here is we have some auto-generated code that RobotBuilder did for us up here. First of all, we have a robot drive, okay, and we know linked to that robot drive we have two speed controllers, a left and right motor. And so we're going to be making this subsystem work with tank drive, and by default, which is this section here, inside this default command here, we want it to drive with the joysticks. And so anytime you get within a new subsystem, the first thing you want to think about, what are all the possible things that I want this subsystem to be able to do? And so the first thing that we want our subsystem to do, and the first function that we're going to make this subsystem do, is we want this subsystem to drive with joysticks. And so I'm going to make a function here, public void, and we're going to call it drive with joysticks. And it's going to take two arguments. It's going to take, we want it to take the kind of joystick values from our Xbox One controller. So in this case, we're going to say, we're going to take an argument of a double, and we'll say left joystick, and then another argument of double right joystick. And then inside of here, what we're going to have this do is we're going to draw upon the actual functions from this kind of drive class that are pre-established in the libraries by WI. So when you're thinking about that, so we can type in drive here, and it's going to give me access to those member functions. So I'm going to go down, and what we actually want to do is we want to do a tank drive. And so you can see it's going to take those same arguments that we have. So I can have left joystick. You can see that tank drive needs to take double value, and then I can have in this one here right joystick, and that's fairly straightforward. Okay, and so this would be what would drive our tank. Now notice that the name of this is only slightly different. Drive with joysticks, only slightly different than the command that we have, drive with joysticks here, we're actually going to call, that's going to be the primary function of this command here, is to call upon the function within your drivetrain to drive with joysticks. Now the other thing that we're going to have is I'm going to make some commands that are going to help out for things like autonomous mode. I could link these to buttons. Okay, I'm actually going to just have inside here a command or a function that's going to just drive our robot forward for a second. And so let's kind of see how we would consider doing that. So first of all, we're just going to make it, so we need a drive forward function. We don't know how long that's going to be for now, but for now I'm just going to type in the function drive forward. We're going to make it timed eventually. So we're going to go drive forward. It's not going to take any arguments for now. And with that drive forward, obviously we're going to want my tank drive again, because that's the kind of system I'm working within. And it needs to take a double value though here. Okay, and if I want to go forward, obviously I need both my left and right wheels going in the same direction. And so up here I'm just going to add a variable that's going to be speed. And so I'm just going to go up here. I'm going to go this, call this private. It's a private variable. Private double, and we'll call it auto speed, and make that equal to, I'm going to get it just moving forward at half speed. I don't want necessarily my robot to go too crazy here, so I'm going to set the speed of my robot to 0.5, which is 50%. Okay, and I'm going to put that 50% down here. Auto speed, and there. Now the reason why I'm keeping this variable within the actual drivetrain subclass itself is I just like to have everything that's kind of related to that subsystem, all the kind of variables that are involved there, kind of easily accessible right within that there, rather than kind of trying to store them somehow in the commands would be a mistake. Another place I might consider storing variables like this though would be in the robot map, just for the way what makes sense to me in my mind is I like to keep those variables right within the actual subsystem itself. Okay, so the next thing that I actually want to have after driving forward, okay, is I want to have the ability to drive backwards as well. And so I don't know why I put public there. I'll just comment this last, drive forward, and we're going to have a function that's going to be drive back, and it's going to look just to save some time, it's going to look exactly the same with a few exceptions. I'm just going to change this to drive back, and with that it's going to take auto speed again, except this time auto speed is going to go to the negative. So I'm just going to change that auto speed to negative. So I have that set up there to the negative. Okay, so that's fairly straightforward. Now from here, the last thing that I want my my drivetrain to be able to do is stop. Okay, I need my drivetrain so that it can stop, say if another command is initialized or whatever. So I'm just going to put in a function here, and we'll call it public void stop. It's not going to take any arguments. It's really going to just do that that tank drive command. So I'm just going to go drive tank drive, and it's going to set the speed rather than to a negative or a positive. Go forward and reverse, it's going to be set to 0. So we don't need any special values for that. We're just going to set that to 0, and then that's all there really is to that's the main functions that are going to operate our drivetrain for now. So I think we're going to add some other variables up here just because I'm going to keep some other stuff up here later on. So from there, just kind of starting to look at, okay, I have the drivetrain set up, I have the functions I need for the drivetrain. Now, next thing I want to do is I want to kind of move towards, okay, I want to start programming this, and the first command that I want to execute is this drive with joysticks. So let's take a look inside drive with joysticks and see what we have there. So inside here, the first thing you'll notice in commands, okay, is they always extend that command. So that gives them all the methods of this command. And you can see some that are here already. We have an initialize section, we have an execute section, we have an is finished section, and we also have an end and interrupted section. So we have a bunch of functions that we need to complete some information in to operate this command. Also, one thing to take into note here, auto-generated as well, is we have the requires robot drivetrain. So this command is directed towards that drivetrain subsystem that we just built. Okay, so keep that in mind as we go along. So when we want to drive with the joysticks, to think about that, we set up the UI so that inside that kind of OI, not UI, we set up the OI so that when we run, if you take a look in here, drive with joysticks, we're going to only run that when we actually are moving the joysticks, and as soon as we stop moving the joysticks, it's going to stop doing that. So when you take a look at this drive with joysticks, we really want it to operate on the execute command. So we want it to operate whenever you kind of feel a motion from the two joystick controllers. We want to be able to kind of move those wheels right away, and then when you release them, okay, we shouldn't be moving. So we want to actually have robot drive with joysticks happening inside the execute. Okay, unlike a button push, as soon as that button's pushed, we want to initialize it. Execute, we want to only run while that's happening. So taking a look inside the execute here, what we want to add to that is we want to add in robot, and we're going to refer to drivetrain, and we're going to go drive with joysticks. And you can see these kind of autocomplete is starting to come up there. And what we want this to take, the value that we want to take for this is the thing I had to kind of look up for the Xbox controllers. Robot.oi Xbox1, which is our joystick, and we want it for the left side. We want to get raw axis 1, which is going to be the stick value on our Xbox controller. So I had to kind of look up what this get raw axis is. And then the other controller, okay, the right-handed controller on my Xbox One, I need to do that by going to robot.oi Xbox1 and then get raw axis, and this time around it's 5. Okay, and so that's going to run. This is basically how simple the command is. It's going to run our tank drive. So fairly straightforward. Okay, now below that though, we have a few things we need to clean up. First of all, we need to kind of complete this is finished, or this end kind of function. So what we want to have happen in that end function is we want to again refer back to that drivetrain. So we're going to again refer to that by going robot drivetrain, and this time around let's not call drive with joysticks. Okay, we could do that and set it to 0. We're going to call stop. Okay, because we know what that does is the stop command that we just made back in our drivetrain, we know sets that tank drive to 0. Okay, we know that's the case. And then when we want to use that end function is if it's interrupted. So if another button's pressed that overrides the drivetrain, we want to be able to stop so we don't do something bad to the motor or whatever else. Or have two values going in opposite directions or something like that. And so inside here, we can just put that end. And that's really all there is to the drive with joysticks. Okay, we don't need to do anything on initialize here. We just want this happening on execute. Okay, and what execute does is basically repeats the command until the condition is not met with in our OI. Okay, and so that would be the joystick values in this case, which it's going to be getting right away. So just kind of get your head around that little bit there. Now, the next command that we're going to work with that was from within the drivetrain was our DriveForward. Okay, and our DriveForward, we're gonna set that on a bit of a timer. We could set this also linked to a button, but we're not going to do that in this case. We're just going to keep this drive forward and drive back as part of our kind of commands that we can use in our autonomous mode if we want to drive forward for a certain period of seconds or drive back for a certain period of seconds. So just going within our drive forward, start with drive forward command. First thing that we're going to do is we're going to set a variable here, and it's going to be double. We're going to call it increment, and we'll go runtime equals. Now, problem is I don't want to really have this variable just kind of set here. I could just put double increment runtime equals 1 second, okay, and leave that here. But to me, that's a really poor place to store this variable. So what I'm going to actually do is I'm going to go back and I'm going to go into our drivetrain. I'm going to put a public variable here, right with the other private one. Okay, and so I'm going to go public double, and I'm going to put run time forward, and I'm going to store this here as 1 second. And the reason why I'm going to do that, I'm going to do the same thing for the next, because I'm going to have runtime back as well. Double time back equals 1.0. Like I was just saying, I'm going to put these two public. Notice that I'm making them public so they can be accessed outside of this actual drivetrain class. I'm making them public just so that, and I'm storing them within the drivetrain though, so that I just have everything that's kind of related to variables of the drivetrain that are going to be inside the drivetrain itself, rather than trying to just store them in the separate commands or trying to store them somewhere else. Like I said earlier, a place that I may want to stick all of this kind of stuff eventually is I may want to move it to the robot map and put it in a section in there that's called drivetrain. But for now, this is an easy enough place for me to access those variables that relate to the drivetrain by just clicking on the drivetrain here and kind of opening that up. But I don't want to, like I said, I don't want to store them just inside the individual commands themselves. So I'm going to go back to this drive forward command. And so that increment time we're going to now set to, I already forgot the name, to runtime forward. Okay, and so the way I'm going to access that is I'm going to go robot dot drivetrain, and this allows me to access that variable I just created in there, runtime forward. And so whatever I put there now, it's going to keep that. Now, the other thing that is new to this command that we didn't use in the last command, where we were operating just inside of that execute function, is inside here we're going to put in what's called a set timeout. And basically what that does is it's built in to the libraries here, and we're going to set that to this increment runtime, which in essence is really just that variable that's going to be stored actually back in the drivetrain. So we'll notice that that increment runtime is right here, and we're going to set that timeout. Now, where we're going to actually put this timeout, so is we want to put this way down, and we didn't use this function in the last one as well, is in the is finished. So when this is true, okay, so when that happens, okay, the set timeout basically takes this value here, okay, it takes a double, okay. When this is true down here, we're gonna so when it reaches that 1 second So we're going to actually have that timed out. So what we're going to have here is timed out, which is another command that is built into the libraries. Okay, this is timed out is just a Boolean, and so when that's timed out, it's going to finish. Okay, so well, what the heck do we want to have happen when that finishes? Well, just like we did before, we want it to stop, so we want to go drive. Robot dot drivetrain, and we're just going to have that dot stop. I'm just going to call that function that we have within the drivetrain. So notice that inside our commands, we're always calling back to functions that are within that actual drivetrain class. Okay, so same kind of thing here. So basically, what's going to happen in this is we're going to actually have this do the command. Now I need this command. Right now I'm not doing anything. I have nothing happening within these two methods here that actually get things going. And so I want this DriveForward to happen on initialize, but only run once. So initialize is only running once. Okay, this function. The execute function just runs repeatedly. So we want this one within there because we only want it to run for that 1 second that we have set back in the drivetrain. And so within here, what I'm going to type in is I'm going to go robot drivetrain, and the function that we want to call for that period of time is we want to go drive forward. So there should be a drive forward function right here. I can just click on that. And so what's happening throughout this command is pretty simple. Notice that it requires a drivetrain. That's what we're using. We've set this kind of timeout time period. I could have just put in a double there and that would have been fine. But I moved that back to the drivetrain. It's going to call that initialize. It's going to run that until that timeout happens. The timeout is going to happen after that 1 second that we have set back over here. Okay, and it's going to drive forward for 1 second, basically, is the way this is going to work. And then that's really all we need, except for down at the bottom here. If this is interrupted, we want to run that end function. That's a local function right here that really runs that drivetrain stop. Okay, and that should be all there is to that drive forward command. So the drive back command should look really identical to this. So I'm actually just going to steal the code from the top here, and I'm going to go inside of the drive back and just make some small modifications to that. So same kind of thing. It's got the requires there. It's got its auto-generated code, and we're just going to go here and put in that increment time this time around. Because I separated them, okay, this is going to be runtime back this time, okay, and you can see the back of the drivetrain I've set two different values there because I might want to go forward a certain amount of time and back at a certain amount of time. Inside the is finished, okay, we want it to be it is finished when it reaches that is timed out. Okay, and so that's gonna, when this set timeout happens, it's gonna end that. We know with inside end, what we want to do is we want to go robot dot drivetrain, and we want to go stop. And we know that end function down in interrupted here is just going to be called so that ends off. Okay, and then all we have to do here now, okay, well, we haven't even done anything yet. Okay, we've got all the kind of how that stops, but now we want to make sure that that's going to drive back, and in this case we're just going to run that function robot drivetrain, and we want it to drive forward, drive back this time around. And if we kind of take a look back and, well, what the heck does that do again? Well, all that does is it sets the speed back here to whatever our auto speed is there, and it's going to drive back at that speed. And you can see that speed in drive back is a negative speed, so it's going to go backwards. Now, one thing I forgot to do is notice this section here. I kind of went through and I did both the commands for drive forward, drive back, and drive with joysticks. And drive forward and back are going to be commands that we're just going to use in autonomous mode. But notice here that there's this section here that says initialize default command. Okay, and so we should have a default command for the subsystem, and we know what that is. We know that the default command that we want for this subsystem is this drive with joysticks. Okay, we want that happening. That function is controlled by this command drive with joysticks. So we need to be able to select that. But since we can see that this can be done in RobotBuilder, let's do that in RobotBuilder rather than doing it by hand. So let's kind of just save up, and then let's go take a look at RobotBuilder. If I go inside of the Drivetrain for RobotBuilder, notice that there is this section, okay, that says default command, and within there, it's simple. I have all of my choices here. What do I want the default command to be? Well, I want it to be drive with joysticks. And then I just can quickly save that, and I can hit Java, and it's going to say down at the bottom that that was exported for me, and then I can flip back to my Eclipse, and right away it put in that command for me. So we know that by default, okay, we're going to drive with joysticks. Okay, and it's going to get those values, and it's going to get all that going for us. That's it for the drivetrain. Let's take a quick look at the elevator. Now, when you look at the elevator, and I've kind of added in some variables here, by default it doesn't have these, so just I'm going to cut that out here quick. Looking here, what it has generated for us though is a speed controller drive, okay, and it's got a default command here too. We're not going to use that necessarily for our elevator because we're going to have everything happen on button pushes. So we don't really need a default command working within there. So what I'm going to add in is I'm going to add in very similar variables to what I had in the drive back and drive forward. And I've kind of jumped the gun here a little bit. And that is I'm going to have a speed, which was auto speed in drivetrain. I'm going to calling it elevator speed in here. And then we're also going to have commands that increment up and increment down. If you take a look at our commands over here, you can see I have an elevator down, I have an elevator increment up, increment down, and elevator up. So what we want to do first of all is kind of put some of those things in. So we want, these are going to happen not by the default command though, they're going to happen on button presses because we programmed in those button presses in our OI. So if I quickly just go to the OI and take a quick look here, you can see that all of my elevator stuff, okay, is declared here, okay, and attached to our controller and on the when pressed and when held kind of events of our kind of Xbox One controller. So just going back to that, let's just kind of start with the start. So we want to go, the first thing that we need is we need when kind of a button is pushed down. So let's go public void, and we'll call this elevator up, and it should be taking at this time it shouldn't have to take any arguments, okay. It should be fairly straightforward. If I want my elevator to go up, I'm just going to put in a function on that drive, and notice it was the type of a speed controller, so it has some different kind of functions than like an actual drive. So let's call this, we're going to set the speed, which we have up there, and we want our elevator speed. Okay, and so we've set kind of our elevator speed there. And then we're going to have a function that looks almost the same. We need our elevator to go down as well. And I'll just call this elevator down, just copying some code to kind of speed things up. Elevator down probably should be set to a negative value. And then we should have another one that we're going to call and I'll just copy and paste again, public void. This time we're going to call it stop. And obviously when we're in stop, we are going to have our elevator speed is just going to be set to 0, which I can just hard code that in. That's fine. And that's the 3 things that our elevator really can do: up, down, stop. And we're just going to use those differently from within our different commands. And that's why we kind of have these public variables that we're going to be able to access for different things. So taking a real quick look at the first one, let's do on the one that's controlled by when we hold the button down. So let's just look quickly at elevator up. Okay, we want this to happen obviously just like the drivetrain within the execute. Okay, we want that to happen within the execute because we want just it to run within the execute. So what do we want to do there? Well, we probably just want to go robot drivetrain, and we're just going to say no, not drivetrain, lose my mind, elevator dot let's go, what do I call that, elevator up? Sorry, sometimes you got to refer back to, that's what I call it, elevator up. And so that's all I really need to happen within there. Okay. Beyond that, I know I don't need to really program too much more here. The only thing I want to have in here is I definitely want to have the ability to stop in that end. So again, that's going to be robot elevator and stop, and then that's going to be my end command. I'm going to that's only going to fire really when I get down here to that interrupted by another command. And that's really probably all I need in here, okay? Because this is going to run while, remember I have this linked to the OI, so it's going to run repeatedly while the button's down. Well, as soon as I release the button, that's going to stop running. So the next thing we can go into programming is while we press the button down, which is our next command. So the next command is going to look very similar to elevator up, which is elevator down, and it's just going to be control again in our OI. Just looking back here quickly, it's controlled while a button is held, right? So since it's controlled while a button is held, it just needs to operate within that execute function of the command there. So let's just open that up and see what we have. So as usual, it requires the subsystem that it needs, and then we don't care about initialize because it's going to actually just happen while the button is pressed down. So it's just going to execute over and over until that's no longer happening, no longer true, and it's not going to execute anymore. So robot elevator, and again now it's just going to be elevator down. And so we know that that's going to just refer back to that elevator down function. Anytime I want to, well, what the heck does that function do again? Well, back into the elevator. Okay, elevator down moves at a negative speed that we've set here down. Okay, so that should make sense to you. When do we want this to be finished? Well, we don't really need that function either because we don't have any timeout. Do we need an end? Yes, we do. We need it to end at some point. Robot elevator, and we need it to do the stop function. Okay, and you can see that is coming up for me right away. And then when the heck do we want this end to actually happen? Well, if it's interrupted. Okay, is the only time. And so that's all there really is to programming those commands for elevator up and down. Very simple, straightforward from that point. Now, the increment up and down are going to resemble very closely. You're going to notice a lot of repetitive code in this. They're going to resemble very much our drive forward and drive back. So let's just kind of take a quick look at drive forward and see how we did that. Well, we kind of had this timeout variable that we set here, and that linked back to those variables we declared in our drivetrain. So this time we're going to declare those in the elevator, so you can see I already did that here. But I'm just going to be lazy again. I'm going to steal that code from drive back even, sure, and do something very similar within our, in this case, we're going to go increment up. So, increment up is just going to run for a period of time up. So, I want to make sure I'm outside of that kind of auto-generated code. And what do we got here? Double increment runtime equals, we don't want drivetrain, we want elevator. Elevator, and what did I say? Increment runtime up is what I need. And so, and that's going to put increment runtime here, and then we kind of have that timeout value. We know we want to set that timeout, okay, is timed out. We want that to happen within that is finished. Okay, so is timed out, and that's part of the library there, so that's going to grab that. If you want to read more about it, click on this link and it'll be okay. So that's set up. So we know when it's going to stop, and I set those values earlier when I established the elevator as up. It's going to go for 0.9 seconds. Down, it's going to go for 0.7, and so that's all set up. What else do I need to do? Well, I need this to start on initialize. Okay, so as soon as I press that button, this needs to go. So robot, and I only have a few things. Elevator, and we can really only do elevator up. Okay, so it's using that same function, okay, that we used in just the regular elevator up. This time though, it's going to time out. Okay. Other thing that we want to again have in each of these is robot, elevator, and I need that stop command. And so I have that in place, and then that again happens when it's interrupted. It seems a little redundant there, but that's okay. So that works. So I have now programmed in, just kind of using the same kind of repetitive model, that increment runtime up, and again I'm storing that for now in the elevator itself, that subsystem. Like I said, these may want to be moved to a separate section of robot map eventually, but for now these variables can be stored there. And so the last kind of command that I need to do for my elevator is I need to do the increment down. So I'm just going to copy this again, just do a little stealing from that one. Make sure I go under the auto-generated code. Okay, my timeout time is going to be this time. It's different. Set runtime down, I believe it's called. Let's check that back in your elevator. I want something to happen on initialize when that button is pressed, because in OI it's linked to button pressed. If you remember that. Just always reviewing. Okay, this one is when pressed. Increment up and down are on when pressed. So it's their when pressed. So it's only going to happen one time, and we want that to happen just on that initialize. So robot, elevator, and this time it's going to be, we want to go down, elevator down, and that's fine. I don't want to do that, do I? Sorry, wrong. That's the wrong one. In elevator down, I want increment down. I don't want to mess this one up. Hopefully I didn't do that. No, I didn't. Where's increment down? There we go. So we want that inside the initialize here. Oh, that's not what I want to see. I'm trying to copy and paste one. Not robot, elevator, and we can go elevator down. Easy enough. Okay. And so from there, nothing's going to happen within the execute, because we don't want anything continuous. We do want is timed out set. So is timed out, which is going to grab that value from back in the elevator, which is going to time out after 0.7 because we're working with gravity. so many here, that's why I can't access these easily. So we're going to go there. So we've initialized, nothing in execute, is timed out and is finished, and we just want this to be able to stop. So inside here, robot, elevator, stop, and again pass that down to the interrupted method, and we should be all okay there. Okay, so that should be it for programming kind of our elevator. Everything should be linked to the UI. Our drivetrain is set. Everything is looking pretty good. So now, once all our commands are in place, and I don't have the robot here to actually run this, I should be able to run this as is right now with the controller. Looking at the grand scheme of things, you can see inside our robot, we have those two subsystems initialized. The drivetrain by default is driving with the control sticks, and then we notice that we have buttons that we can press that within our OI that control all of the elevator kind of functions. Okay, so we have events for all the elevator stuff. And then notice that here it's added a whole bunch of nice stuff for us in Smart Dashboard, which is good as well. And then all this stuff that needs to be declared and has been declared is inside that robot map, first of all. So everything's looking good. Now, you're thinking, well, how do we do autonomous from here? Well, I do have one autonomous command that we created. We created a command called practice auto. And making autonomous, and it was a command group, if you remember. If I just open this up really quickly, notice it wasn't just a regular command, it was a command group. Now, command groups are nice because you can grab your other commands and throw them in here, and it's very easy. And so in my autonomous, let's just make a very simple autonomous. Well, at first, and they got kind of examples here, I want my autonomous to first of all, I'm just going to steal that from there. I want it to add parallel, and I want it to, first of all, what command do I want it to do? I want it to drive forward. I knew I made drive forward for a reason. Okay, and so that's how we kind of initialize that. It shows you the exact example how you do this. So in parallel, I want to drive forward, and I also want it to, I'm just going to add parallel. It means it's going to do at the same time these two things. A new, and we're going to say elevator, and this time we're going to go increment up. So it's going to go up for that 1 second. So it's going to drive forward and it's going to increment up. Then we're going to get it to in sequence, so this is going to be after that's done, so I'm just going to steal that again. In sequence, I'm going to get it to, this time around, let's get it to elevator down. Increment. Increment down, and so it's going to drive forward and lift up our elevator, and it's going to move the elevator down, and then after it's got the elevator down, let's get it to move back. So simple, just autonomous command that really doesn't do too much. And drive back. Okay, but that's all that really is needed within command group. It's just linking together a bunch of commands, so it's awesome. It's quick, easy. You can see why you want to use this command-based mode, because when you get to autonomous, this is easy to switch up and play with and get set the way you want. And so from here on, now all I need to do is go back to my robot and kind of declare this practice auto as my kind of default autonomous command. And maybe I can do that within RobotBuilder. Let's just kind of take a look first and see if there's any space there that can happen. So if I go back to my just robot, which is your main kind of class where everything happens, okay, and like I said, you can see when that's initialized, it starts the drivetrain and the elevator. And then from within there, you can see, okay, they got a autonomous command, but notice that that's within a begin and end auto-generated code. So there must be a way we could just, I could just type in practice auto here, but let's just go do that in see that we can do that within our robot builder. So notice that it's got here autonomous command, and I could just set this to, should be one in here, it's called practice auto. There we go. And so my autonomous command should get set there. I can save this and I can just export that Java. And now when I go back inside of here, boom, it's that easy. It's already set to practice auto. I don't need to type that. And I'm set up to go. I not only have teleop mode set, notice I don't have to really put anything inside teleop mode here. It's really nothing I need to do. I have it set that we're already driving with the kind of control sticks as is. But that's basically it. This is the simple program that runs a simple robot that has an elevator and a drivetrain, and that's all that RobotBot was really last year. So that's fairly straightforward. If you get this example and understand what we did here, you should be able to kind of have the basis for programming almost any robot moving forward. Now, two things that obviously need to be covered in future lessons are specifically PID subsystems, which take an input and give an output. Subsystems like the elevator would generally have a potentiometer on them, so that needs to be covered, as well as Smart Dashboard, which would teach us a little bit about how we get kind of some of these values here as well and play around with those values in testing our program. But that's basically it. Hopefully you have the basis of using RobotBuilder and Eclipse to start programming robots. Talk to you later.